Good afternoon. Today we are doing derivatives. So we are still on grade 12, paper 1 from 2018, November. So, which is question number 8. They're asking us to derive the derivative of fx from the first principles if fx is given as x squared minus 5. So we are given fx is x squared minus 5. So they're asking us to determine f at x from first principles. So from first principles, we know that f at x or dy over dx is given as limit where h approaches 0 of f at x plus h minus f at x, they are all in brackets, over h. So this is the formula for the first principles. So when they say you must determine a derivative of a function, this is the formula you use. So we are given fx is x squared minus 5. So the first step you do, you determine this function, which is f at x plus h. Then this fxx you are given already here. Once you have determined this one, then you come back to this equation. So we first gonna determine f at x plus h. So from f at x, wherever there's x, we replace it with x plus h. So we've got x plus h squared minus 5, which is x squared plus h. I'm just going to try to simplify this so you understand. So x by x is x squared, x by h plus x xh. Then when we multiply this one, h plus x is another xh. H by h, sorry, h by h is h squared. Then we minus 5. So we can remove the brackets. We've got x squared plus hx plus hx plus h squared minus 5. We've got two like items. We can add them together. So x now we have x squared plus 2hx plus h squared minus 5. So that is our f at x plus h. Now we're going to take this and put it in the formula for first principles of the derivative. So now our derivative of x is equals to the limit as h approaches 0. Now we are replacing that. So f at x plus h is x squared plus 2x xh plus h squared minus 5. Let's put it in brackets. Then we are minusing f at x. F at x is given as x squared minus 5. So we put it here, x squared minus 5. So they are all in one bracket, all divided by h. Therefore, we've got the limit as h approaches 0. Now we're removing the brackets, the smaller brackets inside. We've got x squared plus 2h xh plus h squared minus 5. We remove the bracket this side, minus x squared, negative and negative 5, it gives us plus 5 all over h. So if you look at this, we've got like items, x squared minus x squared, they cancel each other. Negative 5 and plus 5, they cancel each other. Then we are left with the limit as h approaches 0. We've got 2xh plus, we're here, 2xh plus h squared over h. which is equals to limit as h approaches 0. We can take the h out and see. So if we remove h at the top, we've got 2x plus h over h. And this h will cancel with that h. Therefore, we've got limit as h approaches 0 of 2x plus h. Therefore, the answer is, so the limit as h approaches 0, we replace h with a 0. Therefore, we've got 2x plus 0, which is giving us 2x. So this is how you solve the derivative from first principle. Then the second part, I'll just do this very same question, not from the first principle, with the simplest way. So a question can come, they ask you to do a derivative of a function, either by from a first principle. If they don't specify to you to do it by first principles, you can just do it the simpler way. So we're gonna find a derivative. Let me just say this is 8.1.2. So fx is x squared minus 5. Then the derivative of x is, the formula for the derivative, the straightforward one, is if you are given let's say you are given fx is xn maybe minus, if it's xn for example, so then the derivative will be, you bring this to be n multiplied by x exponent n minus 1. If we had a variable here, a constant, let's say k, so a derivative of a constant is 0, then our f at x was gonna be that n by xn minus 1 plus is plus 0. A derivative of any constant is 0. So let's solve it here. So here we've got x squared, f at x is x squared minus 5. So derivative of that, we're going to bring to this side, multiply by x exponent 2 minus 1. And then we are minusing 0. Therefore, derivative of x is 2x exponent 1. Therefore, that derivative is 2x. So you see, the answer is the same. So in the exam, you must be careful. Don't rush to use this method. This is a shortcut. But normally they will ask you, like they did here, use first principle to get the derivative. So if they say use first principle, this is the equation for first principle. You have to do it the longer way. But if they don't specify, so you can do it the quicker way, which is this method. Yes, hopefully you understand. Have a good day. Bye.